everybody. Hope you're having a fantastic Tuesday. I have to think about it for a second. Do you guys have to do that too? I think it's just, it's been a long week. We had those severe storms on Sunday. We had severe storms last Sunday. So at least for me personally, instead of 5-day work weeks, it's been 6-day work weeks. So everything starts to go together. And I think because kids are home, we're not going to school. You almost forget what day it is too because you're home every day. So hope everyone's having a great day. The weather is beautiful outside. It is amazing. So I'm hoping you get to go out and enjoy the beautiful weather. We were just out earlier and I had a snake like this long in my driveway. And we had to start opening Google and figuring out what kind of snake it was because we thought it might be a copperhead. But thankfully, and if you know what a copperhead is, you know that's not good. We stay away from copperheads. But according to Google and my expertise here, which is not very much, it was a brown snake. So brown snakes are okay. So as you do go out, just remember there are critters out there. If you see anything cool, snap a picture and send it to me. Tell me what kind of things you're finding outside. Something else interesting, I might have to post on here. Maybe you guys can help me see what it is. I have this weird mushroomy stuff growing on one of my trees and it's going up the entire bark all the way to the top. And it's like, they're like a bunch of little mushrooms growing out the side all the way up. So maybe I'll post a picture, show you guys. Maybe we should do some World of Weathers on that. Not that it's weather related, but it's science related. So maybe we can take it outside for some of our lessons as we continue through May. So, excuse me, I hope everyone's having a great day. Today's topic is hail. And hail is what you see in a severe thunderstorm or in a thunderstorm. It's little pieces of ice pellets. And hail is not to be confused with sleet. They are completely different. They're not even on the same page. And we are actually going to have in the future, a couple weeks from now, we're going to do a lesson where we explain the differences between sleet and hail. But just so you know, hail has to be during a thunderstorm. Has to be during a thunderstorm. You can't have sleet during a thunderstorm. Sleet is actually associated with relatively nice weather. Hail is during a thunderstorm. So hail is thunderstorm, sleet is a winter weather event. They're completely opposite. Yes, they're both little pellets of ice that fall from the sky. But again, hail, severe weather, thunderstorms, sleet. It's what you get with snow, what you get with ice, what you get in the winter months. So don't confuse the two. So we're going to talk about how hail forms. We're going to talk about what causes it and what makes it big, because we'll have pea-sized hail, you can have golf ball-sized hail, you can have softball-sized hail. So hail can vary in sizes and they're created the same way, but there's a special process involved as to what size hail you're going to get. And obviously the bigger the hail, the more damage you're going to see. You don't want to see softball-sized hail. That's like this big. That would hurt your roof, that would hurt your car, and that would hurt you. So we don't like seeing the big hail. That is associated with very tall thunderstorms, with very severe thunderstorms. Smaller hail, you get in some of the thunderstorms that we see pretty often, and actually not very unusual to see pea-sized hail across North Georgia. So today we are talking about hail. As always, I have you on my iPad here on my Facebook Live. There is a little bit of a delay, so I won't be able to get to your questions right away, but I promise I am watching and I am going to answer your questions. So everyone is saying hi. Let's see who's on here. Butch, hey, so glad you're on. We've got Lillian, we've got Yardis, Jackie. Hi, Jackie. Hi, Zach. Hi, Carol Ann. Hey, Gerald. Hey, Kimberly. You're watching from Rome. How are you? Hi, Patricia. Paul is here. Paul's in the house. Let's see. Adam, thank you for sharing this video. Gerald. Let's see. Oh, my voice is lower than usual. I don't know. Let me turn my microphone up. See, that's why I'm glad you're telling me this, Bob, because I think it's up. I can turn it up. Let me see. Hold on. Bear with me. Maybe not. Tell me if you can't hear me, and I can put in a microphone. The only problem is when I use a microphone, sometimes I'm too loud. But I can do that so you can hear me. Okay, so we have it. So just let me know if it's not good. Okay, so World of Weather for today, we're talking about hail. And let me turn this down. And let me turn off my email, because what's happening is people are emailing me. And then you're hearing beep, and then you're seeing my emails. Nobody wants to see my emails. Maybe you do, but. Okay, so here we go. Weather. We are talking about hail. So let me adjust the camera here. Okay, so first, how hail forms. And I am way too close. You're not seeing the entire thing. There we go. So how hail forms. So when you have a thunderstorm, you have what we call updrafts. Updrafts are strong currents of rising air. So imagine an elevator. It's like warm air that's taking an elevator up in the clouds. And when we have these updrafts, which happen in thunderstorms, and you can see the arrows pointing upward, you have little droplets of water. And these little raindrops are carried upwards by the thunderstorm. And as they do, it gets colder and colder and colder. So in the atmosphere, the higher up in the sky you go, the colder it gets. So on the ground, you have updrafts and it's taking up water, but it's just raindrops. But that water is up in the updraft and you're going to hit the freezing level. And that's the level where we are below freezing, 32 degrees or below. So what once was just little droplets of water go way up in the sky where it's cold enough to turn into ice. So then that water turns in tiny, tiny, tiny little pieces of ice. Once that ice gets heavy enough, or the hail, it starts to drop out of the cloud. And as it's dropping out of the cloud, the updraft, which is still bringing that air up, is picking that little piece of hail and bringing it right back up into the clouds where it refreezes. Each time that little water droplet refreezes, another layer is added to that little piece of ice. So it can start out as a little piece of ice, it'll drop, it could go back up, gets a little bigger, it drops, it goes back up, gets a little bigger. It gets to a point where the hail is just too heavy. It won't be sucked up anymore. So eventually, the weight of the hail, because it's so heavy, exceeds the force of the updraft and the hailstone falls. So this is important is because, again, you have the updraft. The stronger the updraft, that rising air, the bigger the hail you're going to get, the stronger the thunderstorm. So the stronger the thunderstorm, the stronger the updraft. During a thunderstorm that's not very strong, as that hail gets to the pea size, tiny little piece of ice, it'll drop. And that's heavier than the updraft, so it will fall to the ground. On the other hand, if we are in a severe thunderstorm and we have a very powerful updraft, it's a little size of pea hail, the updraft is going to pick up that little size of pea hail and it's going to take it right back up, and that little pea hail is going to get even bigger. And then it's dropping and it's even bigger, it's even bigger. And that updraft is so strong, it's going to pick that piece of hail up, bring it back up, and it's going to get even bigger because it went up again in the clouds. It has another layer of ice. Now you've got a bigger piece of hail. Then you've got another updraft, takes it back up, it gets another layer. And then eventually it's so big that the updraft doesn't take it anymore, and then it falls down to the sky. So the stronger the thunderstorm, the higher the thunderstorm, the stronger the updraft, the bigger it's going to get. So hopefully that makes sense. So again, you have these little water droplets that are going up in the updraft. Those little pieces of water go past the freezing level. Once they do that, they turn into little pieces of ice. And once the ice is heavy enough, it is going to fall to the sky. Now, depending on how many times that hail keeps getting lifted in the updraft, that determines how big the hail is going to be. And we talked about the different sizes. Pea hail is the most common. That's about 1/4 of an inch. And the reason, as meteorologists, we can tell you the size, 1/4 of an inch, 3/4 of an inch, 2.5 inches. But we actually use descriptors. We use words. And these are words that all meteorologists use. So we use the same words. Grapefruit is 4.5 inches. That's the biggest size. And as meteorologists, we're all going to say grapefruit. We're not going to use different adjectives for the same size. So even though this is common language and these are common terms, these are the words that every meteorologist will use. So we start from pea-sized hail is the smallest. 1/2 an inch is mothball-sized hail. 3/4 of an inch is penny-sized hail. So the size of a penny is 3/4 of an inch. Nickel-sized hail, so 5 cents, is 7/8 of an inch. 1/4 is 1 inch. A ping pong ball is 1.5 inches. Then you get to 1 3/4 of an inch. That's a golf ball. A hen egg is 2 inches. A tennis ball is 2.5 inches. A baseball is 2 3/4 inches. A softball is 4 inches. And then the biggest is the grapefruit. And a grapefruit is 4.5 inches. And this shows you what is considered severe. When we have pea hail, mothball hail, even penny hail, we don't consider that severe. Usually in order for a thunderstorm to be severe, we need to have 1 inch hail or greater. So a lot of times in a severe thunderstorm, if we don't have the winds, but we only have the hail, that's what makes it severe. If it has 3/4 of an inch hail, it is not considered a severe thunderstorm. Once you have 1 inch or greater, it is considered a severe thunderstorm. That's when we would have a severe warning on that thunderstorm, a severe thunderstorm warning, when it has 1 inch or higher. Now, you may have a storm with 65-mile-an-hour winds and a quarter-sized hail. That is still severe because of the winds. So the thunderstorm has to meet certain criteria. It just has to meet one of them. So it could be the winds, even though it has smaller hail, or it could be bigger hail and lighter winds, or it could have both. But you need at least one parameter in order for a thunderstorm to be severe. When it comes to hail, it has to be 1 inch or bigger. That is 1/4 or bigger. And we've seen some hail here in Georgia, but normally we get pea-sized hail or mothball-sized hail. And you can see on the bottom how common it is. When you're talking about grapefruit or softball hail, that can be incredibly dangerous. But luckily, that is exceptionally rare. We don't see that, especially in Georgia. Baseball and tennis ball hail, that is very rare. And then the smaller, the more common it is. So big hail, not so common, thank goodness, because that would really hurt. Smaller hail, that is what we tend to see here in Georgia. But we've seen some bigger hail. We have. In 1998 in Estelle, we had hail that was about 2 3/4 of an inch big. That is big. 2.5 inches in Blue Ridge in 2004. In Decula in 2018, 2.5 inch hail. So it's not out of the question. We've seen it, but more than likely, it's usually pea-sized hail. Here's some pictures we've gotten from viewers over the years. This was in 2018 in Decula, and this was from a viewer, and this was 2.5 inch hail. And I'm going to push this in so you can see, because hail is actually quite beautiful to look at. It almost looks like an ice crystal. It's not uniform. It's not a perfectly round ball. It doesn't look like a golf ball or a hen egg or a baseball. So we use these words to tell you the size, but as you can see, it's very irregular in shape. And again, we talked about the process of how these form, how they get sucked in these updrafts and fall back to the earth. That helps explain its shape. It's not a perfect circle. It doesn't look like a baseball. It looks like these ice crystals that come out of the sky. So that was actually yesterday's trivia. I'm going to ask you today's trivia question. And today's trivia question is, what is it called that sucks the air up into the thunderstorm that carries the little droplets of water that create hail? What is that with the arrows? It's basically a strong current of rising air. That's the dictionary definition. A strong current of rising air is an updraft. So the answer to today's question, it is an updraft, and that's what carries the hail up. Again, hail happens with severe thunderstorms or with thunderstorms in general. You need an updraft. You need a very powerful storm. Another interesting thing, we talked about the size of the hail, and it has a lot to do with how many times the hail goes through that process of being sucked up in the updraft, coming down, sucked in the updraft, coming down. But another thing is, the taller the thunderstorm, the bigger the hail, because usually the stronger the storm and the stronger the updraft. We have some thunderstorms that are more than 50,000 feet high, which is way up high. Just to give you an idea, airplanes fly around 32,000 feet. So you're talking about thunderstorms that are almost 20,000 feet above where airplanes fly. So the taller the thunderstorm, the more powerful the thunderstorm, the stronger it is, and the bigger the hail can be. Also, just how strong that updraft is. Even let's say it's not 70,000 feet in the air, but maybe a 50,000 foot thunderstorm, and you just have a really strong updraft. You get that pattern going, and you get that hail that's really, really large. So I'm going to see what kind of questions we have. Hopefully you understand what hail is. Again, you only see hail with thunderstorms. You don't get it in the winter with just a regular with regular rain. It happens when you have a thunderstorm. And again, hail does not happen in these storms. It's not hail. It's going to be, or I'm sorry, it's not sleet. It's not sleet. It's going to be hail. See, I'm even confusing myself. Okay, so hi everyone. Let's see who else we have here. What else we have? Kansas City. Wow, I love that you're even watching from Kansas City. You love my home hair? I'm glad you do. It's called lazy hair. Let's see. Oh, Richard, thank you. I'm glad you enjoy the lessons. Let's see. Good here. You sound good on my end. Big hail in the mountains. Sounds good. Bob. So Bob asked, does hail need a seed? So a speck of dust or a spot, or does it only form with water? And that's a good question. Here's the thing. It is water, but it can have a little bit of dust as well. Pretty much any particle you get in the atmosphere is at least going to have a bit of dust. Have you ever looked out your window on a sunny day and you're laying in bed and you see all that dust flying, and then it kind of grosses you out because you realize you're breathing that in, and every time you talk, you're probably going in your mouth? There's dust everywhere and these little seeds everywhere. So these little droplets that go up, yes, they're water, but they have little bits of dust just because it has to. That's what our environment is made of. We have this dust pretty much everywhere. But now you're going to, if you haven't done that yet, look out the window, kind of, you have to get the sun shining in and look at the air, and you'll see everything that's flying in the air. During pollen season, it's even more yuck. Okay. Oh, everyone got it. The question right. Adam, thank you. You like my at-home hair too? So I think that's all. We have no questions, or that was the only question. I hope you guys enjoyed today's lesson. So tomorrow we are talking about lightning, and there was so much information that we're dividing it into 2 lessons because we've had a lot of lightning yesterday, and we'll get lightning on Thursday, and we're getting into the summer months. So I think we need to talk about lightning safety. So I know your mom and dads tell you, or you know, if you're an adult, you know this too, that if you're in a pool, you hear thunder, you need to get out of the pool. And you've probably heard that by the time you see the lightning and then you hear the thunder, you should count 1, 2, 3, 4. And depending on how high you count is how far the lightning is. So we're going to go over, how do you do that? Do you divide it by a certain number? What does each second equal in distance? So we're going to talk about when it's cold and when it's warm. That affects how long you need to give when you're counting 1, 2, 3, 4, because the lightning travels at different speeds. The light and the sound travels at different speeds depending on if it's warm or cold. So there's a lot when it comes to lightning. We're also going to talk about who is most inclined to get struck by lightning, and how does lightning form? Where does it come from? So if you are interested in lightning, make sure you join us tomorrow for the World of Weather. As always, we're on at 1:15 right here on Facebook Live, or on our CBS 46 streaming app. Everybody stay safe, go outside and enjoy, hopefully with no snakes. No snakes today. Everyone have a great day.